In this lecture, we're going to cover complex rational expressions, and this is going to finish up chapter P. And in the next lesson, we'll start chapter 1. So what is a complex rational expression? Another name for it is a complex fraction. And really, the way I think about it is, it's a fraction that contains fractions in either the numerator, denominator, or both. So for example, let me hop over to the whiteboard for a minute. This is an example of a rational expression. Let's say I had 1 over x plus 2 over 3x divided by 1 plus 4 over x squared. This would be a complex fraction. Because if we look at the big picture, this is a big fraction, right? And in the numerator, it contains fractions, and the denominator contains fractions. So it's like a fractions within a big fraction. So it's complex. It's a complex fraction. So in this section, we're going to learn how to simplify them. So let me go back to the worksheet. Now, we want to simplify a complex fraction so that neither the numerator or the denominator contains any rational expressions. So there's a method, really there's a few different ways to do this. I always try to approach things where we use a method, I think, that's the easiest to understand and kind of makes your life less difficult and involves the least amount of work as possible. So the method that I often use to simplify these complex fractions is I multiply the numerator and the denominator by the least common denominator for all the rational expressions. So what that means is if we look at each individual fraction that's within the complex fraction and we find the least common denominator and multiply the least common denominator by the numerator and the denominator, we're going to end up with an expression that doesn't contain fractions now in the numerator and the denominator, and we could simplify from there. And I know that sounds like a lot, but I think once you see an example or two, it's going to make more sense and you're going to see why it works. So let's look at example 30. So for number 30, we want to simplify the complex fraction. So if I look at the expression in A, we have 1 over x plus 7 minus 1 over x over 7. So when I look at this, I see a big fraction, right? It's almost like if I extend this fraction symbol, we see the big fraction, right? The numerator contains 2 fractions, and I also have a fraction in the denominator. I mean, technically, I could write that as 7 over 1, right? So, and one of the methods that we could use to simplify this whole, complex fraction is to multiply the numerator and the denominator by the least common denominator of all the different fractions that we see here. So you see how we see a 1 over x plus 7. I have a 1 over x and a 7 over 1. If we look at these 3 different denominators, what's my LCD? What's my least common denominator? It's going to be x times x plus 7, right? So what I'm going to do is I'm going to multiply the numerator and the denominator of this big complex fraction by x times x plus 7. So look, take x times x plus 7, multiply it by the numerator, and then I'm going to take x times x plus 7 and multiply it by the denominator. And if it helps you to multiply, put it over 1. So we're going to multiply numerators, right? That's how we multiply fractions. Multiply across the numerators, multiply across the denominators. So I'm going to have x times x plus 7 times 1 over just 1 times x plus 7, right? So x plus 7. And then minus, now distribute the x times x plus 7 to this numerator, which is just 1. And when I multiply the denominators, 1 times x, it's just x. Now let's divide that by, now let's multiply the least common denominator by this fraction in the denominator. So I'm going to have x times x plus 7 times 7, and that's going to be over 1 times 1, which is just 1. Do not distribute in the numerator or the denominator. The purpose of this was to eliminate fractions in the numerator and the denominator by multiplying by the least common denominator. So look what happens. You see how I have x plus 7 over x plus 7 is just 1. And then here I have x over x is 1. So by multiplying by the least common denominator, I'm eliminating fractions, but I'm still writing an equivalent expression because I multiplied both the numerator and the denominator by the same expression, x times x plus 7. So it's still balanced. So look, now this is going to look much simpler. All I have is x times 1, which is x, minus, now I have an x plus 7 times 1, which is just x plus 7. And in the denominator, I have x times x plus 7 times 7. So I'm just going to write that as 7 times x plus 7. See how much simpler this looks now. I don't have fractions in the numerator and the denominator now. I just have a single fraction, right? With no fractions in the numerator, no fractions in the denominator, which was the goal. So now let's distribute. So I'm going to have x minus x and then minus 7 over 7x times x plus 7. X minus x is 0, so I'm going to have negative 7 over 7x times x plus 7. And look, we have a common factor. You see how we have a common factor of 7? So we have 7 over 7. And that just becomes negative 1 in the numerator, right? Because 7 is divisible by itself 1 time. So in the numerator, I'm going to have negative 1. And then in the denominator, I have x times x plus 7. And that's going to be my final answer. So that complex rational expression that we started with in A simplified to negative 1 over x times x plus 7. So we're going to use the same technique on the other two examples that we're going to do. So let's look at B. So I'm looking at this as I have a 1 over 1 plus 1 over x over 3 over 1 minus 1 over x. So sometimes it's nice to just take any whole numbers and put it over 1 so we could see, all right, it's like I really have 2 fractions in the numerator, 2 fractions in the denominator, right? In the numerator, we're adding the 2 fractions, the denominator, we're subtracting. But we could use the technique that we just used above, find the LCD and multiply the numerator and the denominator by the LCD, and you're going to see we're going to eliminate fractions, and then we'll be able to maybe simplify that final rational expression. So look at these 4 different fractions: 1 over 1, 1 over x, 3 over 1, 1 over x. You have 4 different denominators, right? A 1, an x, a 1, and an x. What would the common denominator be? The least common denominator. It would be 1 times x, or just x. So what I'm going to do is I'm going to multiply the numerator and the denominator by the LCD, which is x. And like I said, if you want to make it x over 1, just to help you multiply properly, that's fine. So distribute the x to the numerator. So I'm going to have x times 1, which is x, over 1, right? 1 times 1. So I'm just going to leave that as x. And then plus now x times 1, which is x, over 1 times x. In the denominator, if I distribute the x, I'm going to have x times 3, which is 3x, over 1 times 1, which is 1, minus, now distribute x to the 1, which is x, right? X times 1 is x, and then over 1 times x, which is x. And look what happens. X over x is 1, right? X over x is 1, 1 over 1. So in the numerator, I'm left with x plus 1. And then in the denominator, I have 3x minus 1. And if we could factor and try to simplify, we would do so, but the numerator and the denominator can't be factored further. So this would be my final answer, x plus 1 over 3x minus 1. And let's do one more. So for C, we have 1 over x plus 1 over y divided by x plus y, but I'm going to write that as x over 1 plus y over 1. So it's like, okay, I have two fractions in the numerator, two fractions in the denominator. Let's find the LCD of those four fractions and multiply the numerator and the denominator by the LCD. So my denominators are x, y, 1, and 1. What would my least common denominator be? It would be the product of the different factors, right? So really it would be x times y times 1, or just x times y. So what I'm going to do is I'm going to multiply the numerator and the denominator by x times y. So look, we have 1 over x plus 1 over y divided by x over 1 plus y over 1. And let me just change color for a minute. So we're going to multiply the numerator and the denominator by xy over 1. So let's distribute. So I'm going to have x times y over x plus x times y over y divided by x times y times x plus x y times y. And they're both over 1, so I'm just going to leave it. So look, in the numerator, my fractions disappear, right? Because I have x over x, y over y. So in the numerator, all I have is y plus x. And then in the denominator, I could write x times as x squared times y. Plus now x times y is just x times y squared. And let's see if we could factor the denominator. So I'll continue down here. So in the numerator, instead of writing it as y plus x, I'm just going to write it as x plus y, right? Just alphabetical order. And then in the denominator, between an x squared y and an xy squared, I can factor out an x and a y. So when I divide x squared times y by xy, I'm going to be left with x. And when I take the xy squared and divide it by xy, I'm going to be left with a positive y. And now I see, look, this numerator, x plus y, is the same factor as the x plus y in the denominator. So that's going to reduce to 1. not 0, right? So this is going to become 1. So we're going to have 1 over x times y, and that's going to be my final simplified answer. So this wraps up chapter P, the prerequisite chapter. Like I said earlier, in the next lecture, we're going to start chapter 1.